after having some technical difficulty, we finally got this rolling here, I think. As long as it doesn't want to have any more hiccups. It likes to change screens. I've never seen it do that before. Okay, so to get the rest of you up to speed, what we see on here, okay, we're just naming this compound here, and as you can see, we got two of the same numbers. Here's our parent chain, 6 carbons, and then we're showing that there's a double bond there, and it says it's on the 3rd carbon, and there's a methyl derivative on the 3rd carbon as well. And notice it doesn't make any difference whether you went this way or this way. I guess it does. You have to go right to left since it's not on here. But it's after the 3rd carbon. Okay, there's our double bond. There's a methyl group on the 3rd carbon. Okay. Then, if there are 2 double bonds within a compound, like what we see here, that's what this is referring to, the di portion. Okay. So there's an alkene, or double bonded carbon or carbons, since we see the di portion. There's 6 carbons in the parent chain, and this is where those double bonds are located. Here again, this wouldn't matter. 1, 2, 3, and 4 going this way, or 1, 2, 3, and 4. It just wouldn't matter either way that you would have gone on that compound. Okay, then on this, what we see down here on a ring structure, okay, remember the double bond takes priority for that. And in this case, we also have a alkyl group, or a methyl derivative down here. And what that means is we need to state where that methyl group. And ring structures are a little different than aliphatic compounds, okay? So because we need to illustrate where that double bond is, because it's on the 1st carbon, and we also have a methyl group on here as well. Excuse me. Because if we had this as 1, then that's going to be on 2. So, since there's only 1 methyl group on here, we want to give this the lowest priority. So, if we had this methyl group back up here and took this off, well then we're going to have 3 methyl cyclobutene, because we're not going to go in this direction to give us 4. We're going to start down here, 1st, 2nd, and 3rd. That would be 3 methyl cyclobutene. Again, I'm trying to get you up to speed here because we have a problem quiz on Monday for those of us who are here. You other 2 will just have to come in and get that done, because I think you would agree when we're missing school like this, we can't just stop. Okay, so now what we see up here, we've got this double bonded structure, and remember, we want you to go by the hydrogens that we see here. We've got a double bond, and those are pointing in the same direction, therefore making this a cis compound, and we refer to that as cis. Okay, and how many carbons are in that parent chain? There are 4. It was going down. That bugs me. Okay, so cis, and you correctly said there's 4. So where's that double bond located? Okay, cis dash 2 dash butene. Okay, and if we were to put him down here, then you'd have your trans 2 butene. But we had a methyl group on here, so when we do that, we can get rid of this cis compound. Okay, then we need to find our parent chain. You might look at this and say, oh, well, we can go up in this direction, have a trans compound, but no, that's not the case, because you don't have a hydrogen up here. So, what compound do you think we have here? 2-methyl-2-butene. Okay. be correct. And, oh yes, we had this ring structure on here. This is just more so of a review. If we had secondary butyl, remember 4 carbons, but the S is saying the parent, it's attaching the parent chain on the second carbon. Okay, and if we had a propyl group, that's just 3 carbons, or C3H7, but if we attach it in this manner, then we've got an isopropyl group. Okay, then if we have 4 carbons in this manner, now we've got tertiary butyl, and if we attach it in this manner, then we've got isobutyl. Okay, so those are your derivatives quickly as a review. And then I think that gets us up to speed from where we finally got this laptop decided to cooperate and record. So it's naming compounds or drawing them out, and then finally the reactions. And when we're doing those reactions, what's the first thing that we need to illustrate? This is aliphatic compounds, not aromatics. So it doesn't matter what this is reacting with. Will it have a major and a minor product? No, it will not. So even if we had the asymmetrical reagent, which we'll just pick HCl, even as that reaction proceeds, okay, does this need a catalyst? No, it does not, because these are weak pi bonds that we see in there. So as this reaction would proceed, what we're going to see happening is here is going to form some sort of butane. So we can put one of the chlorines on here, and then that hydrogen looks like we can put it down here. Okay? So now we've accounted for both bonds, and even so, even if you flip-flop them, that's just going to form an equal amount. Even if we had done this, let's say we had 2-pentene instead, okay? The only difference that you're seeing here is now we've got just this extra carbon here, and then these are going to form in equal amounts, and that's why you don't have 2 products for that. As you do, but they form in equal amounts, and we're not too concerned about that. So how do we make this to where we have to label 2 products? Asymmetrical aliphatic compound and an asymmetrical reagent. Okay? So to do that, if we take this guy off, and that would work right there. So now he's gone. So now we've got our 4 carbons. What does this look like to you, the major or the minor product? That's the major product, okay? And remember, what's happening is when this compound splits, this hydrogen is looking for that double bond that already has more hydrogens than the one next to it. This one has 1, this one's got 2. Therefore, this hydrogen then bonds here. The chlorine atom bonds there. That's your major. You flip-flop these 2, Put the hydrogen up here, the chlorine on the end, then you have your minor product. Okay? So, again, when it comes to these reactions, look to see what compound you have. Is it symmetrical or asymmetrical? What are you reacting it with? Is it symmetrical or asymmetrical? And of course, there's always exceptions to the rule, and, well, I shouldn't say there always is, but in this case, what we would have to be concerned about is this guy right here. We're just adding hydrogen to this. That exception would be what? We need a catalyst, some sort of metal catalyst, whether it's nickel, aluminum, iron, platinum. If you have a metal catalyst here, well, then you're going to go ahead and have your reaction proceed. Okay. We on the bus. Okay, so that will get us through on Monday when those students who are here will take that problem quiz. Those that are not, you have to come in and get that made up on your time. So then on Tuesday, we're going to continue with these aromatic reactions and how to utilize that flow chart. All right, so catch up to you next time.